All right, so section 6.5, we're going to delve a little bit deeper into solving and simplifying a radical expression. Some of this will be review of what we did in the P unit, which was at the very beginning of the year. So it seems like some of the stuff we've done already, partially that's true. But a couple key points to keep in mind. Remember, if you have a radical and there's no number sitting where the index is, it is understood to be 2. It is understood to be 2, and it is understood to be a square root. If you have numbers, you can simplify them as much as you can. Expressions, you're dividing the exponents. Again, all even number indices should include a plus or minus sign. Insert the absolute value bars when you have a even exponent divided by an even index. You get an odd result. And then complex numbers, imaginary numbers still apply. That just means if you get I can still be a part of the answer. So again, most of those are the same things that we went through yesterday. So let's go ahead and jump right on in. So example 1. Square root of 64, 8 to the 4th, b to the 9th. So the first thing that you should do to keep everything in order is to separate. Separate all the individual parts. So again, there's no number where the index is located. So this is a square root. Square root of 64 is 8. Since it's a square root, for the variables, exponent divided by the index, exponent divided by the index. 4 divided by 2 is 2. So you have 8a squared. 9 divided by 2 isn't even. So 2 goes into 9 4 times. That's b to the 4th. So since that does not divide evenly, the remainder goes back under the square root. And that's your simplified answer. So just like we did back at the beginning of the year, if you have remainders with your radicals, they go back underneath the radical. Remainders go back in. Whatever worked out evenly gets kicked out. Questions, example 1. Now remember, if you have questions, make sure you ask. Don't wait until you have a quiz in front of you or you have a test in front of you to now panic and realize, oh, I don't know what I'm doing. It's a little late at that point. All right, example 2. Same type of problem, works the same way. Cube root of 729 times cube root m to the 30th times cube root m to the 20th. Once again, same rule applies. So cube root of 729 is 9. Remember, cube root is you're looking for what to the 3rd power will give you 729. For the variables, You're dividing the exponent by the index. Thirty divided by 3 is 10. For the n, 3 goes into 20 6 times. Which means you would have 2 left over. That's 9 m to the 10th, n to the 6th, times the cube root of n squared. Question 1 or 2. All right, so now that we've simplified a single radical, now we're going to go ahead and move into working with multiple radicals. So this is where adding, subtracting, multiplying, dividing comes into play. So we're going to start with adding and subtracting. So adding and subtracting, remember the concept of combining like terms. Combining like terms. So when you have like terms, that's the only way you can combine them. Same thing applies for a radical expression. So right now, for example 3, you have 12 and 27. You cannot put those together because they're not the same radical. So since they're not the same radical, your thought process is going to be to simplify the square roots. So now you got to simplify the radicals. So let's start with 12. So for 12, you need 2 numbers that multiply to 12, one of them being a perfect square. So 12 breaks up into 4 and 3. Square root of 4 is 2. Square root of 3 stays. Now you still have that 4 that was sitting in front. You multiply the 4 times the 2. You get 8 square root of 3. That takes care of the first part of the problem. Any questions before we continue? Same thing with 27. So 3 square root of 27. You need 2 numbers that multiply to 27, one of them being a perfect square. So 9 and 3. Square root of 9 is 3. Square root of 3 stays that way. The 3 that was in front. Now you multiply it. 9 square root of 3. So now you can combine like terms. Because both of them have the square root of 3. 17 square root of 3. Questions, example 3. It's not a hard problem, but it's going to make absolutely sure that you know how to break down the square root. Decimal answers, not allowed. You give the decimal answer, just go ahead and mark it wrong yourself. Says simplify the radical, you're going to simplify the radical. So, all right. And let's do example 4. So right now, none of those radicals are simplified, so that means we had to simplify it. So what are we using for 45? Square root of 9 is 3. Square root of 5 stays. 3 out front. 3 times 3 is 9. So 45 is taken care of. What about for 80? What two numbers are we using? Four. Square root of 5 stays in. Negative 5 times 4 gives us minus 20. And what about for 20? We got 4 and 5. Square root of 4, 2. Square root of 5 stays. 4 times 2, 8. So if we combine this all up, we got 9 minus 20 plus 8, negative 3 square root of 5. If you got negative 19 square root of 5, I know exactly what you did. You violated the order of operations. Remember, order of operations says to add or subtract going from left to right. That means you have to do 9 minus 20 and then take that answer and add 8. Do not violate the order of operations. Question 3 or 4. Oh, let's see them. So, multiplying radical expressions depends on what you have. So if you have two radicals, you're going to multiply radicals together. If you have something that looks like distributive property or FOIL, then you're going to do distributive property or FOIL. Depends on the problem. So let's first gaze our eyes on example 5. So notice that with example 5, both of the indexes are the same. The indexes are the same. So, same index means you can multiply the radicals. You multiply the radicals together. So, you'll still have the fourth root. So you have 3 x to the third y squared times 27x y squared. Three times 27 is 81. X to the third times x is x to the fourth. Y squared times y squared is y to the fourth. Remember, the properties of exponents are still valid. If you multiply, you add the exponents. That rule doesn't go anywhere. Now you simplify it the best that you can. So simplifying in this case, breaking it apart. So fourth root of 81, that means what to the fourth power gives you 81. For the variables, you're taking the exponent divided by the index. So 4 goes in the 4 once. 4 goes in the 4 once. That's it. Problem's over. It actually came out nice and neat. Is that going to happen all the time? Absolutely not. Just saw with examples 1 and 2, it didn't come out nicely. So never assume that it's going to come out nicely. Question example 5. All right, example 6. So with example 6, we have something that looks similar to FOIL. So if it looks like distributed property or FOIL, do it that way. First, outer, inner, left. So your first terms, 3 square root 3 times 5 square root 6. Outside terms, 3 square root 3 times 2 square root 3. Inside terms, negative 2 times 5 square root 6. Negative 2 times 2 square root of 3. Get everything simple up. Separate it out. So now we go to work. 3 times 5, 15. 3 times 6, 18. 3 times 2, 6. 3 times 3, 9. The last two don't have two radicals. They have two numbers sitting on the outside. Negative 10 root 6, negative 4 root 3. Any questions before we continue? All right, and question for you. Is there anything up there that can be simplified? So this can still be simplified. That can still be simplified. So 18 is going to 9 and 2. Square root of 9 is 3. Square root of 2 stays. (45) square root of 2. Square root of 9. Oh, isn't that nice? That's a perfect square. 3. plus 18 minus 10 root 6 minus 4 root 3. Is there anything else that can go down farther? Good. It wasn't a trick question. The answer is no. 2, 6, and 3 are as far as it can go, and you can't combine any of those things. So that is your final answer. So all that's your final answer. So you might see it written with the 18 being in the back. You might see the problem written with the radicals in some kind of order, either least to greatest or greatest to least. But I could care less. As long as everything is simplified, that's fine with me. As long as all the radicals are simplified down, that's good enough for me. Any questions on problem 6? Correct. Well, before we get into dividing, so now we're going to move on into dividing. So dividing exists in a couple of different formats. There's dividing radical expressions in which the denominator comes out clean. There's dividing rational expressions in which you have to eliminate the radical from the denominator. And there's simplifying the radical expression that are a little bit more complex. So there are different levels for dividing, which is why we took the break before dividing. So we're going to work through a couple of them today and probably end up having to finish this up on Thursday. So let's first start with dividing in which the denominator comes out clean. So example 7, b to the 5th divided by 9c to the 10th. So first order of business, take this problem and split it up. Take it and split it up. Now we solve each part individually. So, numerator, you have b to the 5th power. Remember, if it's square root, it's understood 2 out in front. That's b 5 divided by 2. So 2 goes into 5 twice. And your remainder goes back inside. Remainder goes back inside. So the numerator is taken care of. Denominator works the same way. Square root of 9 times square root of c to the 10th. Square root of 9 is 3. C to the 10th, remember there's a 2 out in front. 2 goes into 10, 5 times. So of course you check the problem, make sure there isn't anything that can be simplified. And that's that. Yes, go ahead. Yes, since you divided by even, and that was odd, the absolute value notation would still go around c to the 5th. Now, to be completely frank with you, the book is going to show, the book problems are going to show the absolute value. I'm not a huge stickler for it. So if you're taking a quiz or doing your test and things of that nature, if you forgot it, I'm not going to make a big deal out of it. So, yeah, just know that the book is going to show the absolute value. I'm not going to make a huge deal out of it if you forgot it. Any questions, example 7? All right. Example. So let's simplify. First things first, separate the two parts. First thing is separate the two parts. At the top, you have the fourth root of 81, fourth root of f to the 8th, and the fourth root of g to the 11th. Fourth root of 81 is 3, because 3 to the fourth power is 81. 4 goes into 8 twice, so f squared. 4 goes into 11 twice, so you've got g squared, and then the other 3 g's that are remaining go back underneath the radical. So the top is finished. Bottom works the same way. Fourth root of 16, fourth root of h to the 12th. Fourth root of 16 is 2, fourth root of h to the 12th. 4 goes into 12 3 times. H to the 3rd. That's finished. Any questions or troubles with example number 8? We're going to go problem back into the screen. So notice that for both of those problems, both denominators did not have a radical in them. There was no radical in either denominator. So that's why these worked out pretty nicely. What that does mean is when you do have a radical in the denominator, you got to take care of it. You are not allowed to have a radical sitting at the bottom of a fraction. You will deal with this a lot when we finally get to trig. Trig is normally taught late third quarter, early fourth quarter, and you deal with a lot of radicals. Radicals cannot stay at the bottom of a fraction. So yes, for those of you who are wondering, when is trig coming? Trig comes late this quarter, early next quarter. Hence why they call the class Algebra 2 Trig. So, if you have a square root, cube root, fourth root, any kind of root, at the bottom of a fraction, you have to get rid of it. So the process of getting rid of it is called rationalizing the denominator. Rationalizing the denominator. So we're going to start with a simple case, which is a square root. Start with a square root. So yeah, Evan, you're supposed to put the absolute value, but it's not something that I'm not going to penalize you all if you forget it. Because it's so rarely hinted upon. I made sure to make sure that you knew it in the event that you see it in pre-calc or in calc. But most of the time, we don't care about the absolute value. So for example 8, if you had put it there, then that's fine. Most of the time in pre-calc, we don't pay attention to the absolute value when it comes to simplifying the radical. So if you put it, great. If you don't, I'm not going to take off that. I more so care that you simplified it correctly. All right. So let's rationalize the denominator. We're going to start with a square root. So a square root in its general form is something times itself. Something times itself. So for example 9, you have a fraction, so the first step is to break it apart. So here's the problem. You have the square root of 5. You can't leave the square root at the bottom of a fraction. You can't leave that square root at the bottom of the fraction. So we have to eliminate it. So since a square root is something times itself, if we multiply the square root of 5 times itself, then we should have something that allows us to cancel it out. So we're going to multiply the denominator by the square root of 5 and see what happens. Five times 5 gives you 25. And when you look at that, square root of 25 is 5. The radical disappears. So you force the radical to eliminate itself. You are absolutely right. You can't do it to the bottom unless you're going to do it to the top. Whatever you do to the bottom of the fraction, you better do it to the top. So 18 times 5, square root of 90. 90 can be broken up into 9 times 10. The square root of 9 is 3. The square root of 10 stays. So your answer is 3 square root of 10 over 5. That's it. Problem over. Questions, example 9. You wouldn't be wrong. I mean, if you wanted to break down 18 to get that to 3 square root of 2, that's fine. So when you multiply by the square root of 5, you would only be multiplying the 2 and the 5. So if you chose to do it that way, that's okay. It doesn't hurt the problem. So, great observation there. Anything else with problem 9? All right, problem 10. So problem 10, we're still dealing with the square root, so the same rule applies. Break the two parts up. So once again, you got a square root sitting at the bottom of the fraction. So we're going to get rid of it. Remember, a square root is anything times itself. We're going to multiply the top and the bottom by 3y to the third. So if you wanted to simplify y to the third first, so if you wanted to take this part and simplify it to y square root 3y, that's fine. That just means instead of multiplying by 3y to the third, you would just multiply by 3y if you choose to go down that route. So in my case, I'm choosing to eliminate the denominator and then simplify it later. So it's not wrong as long as you pay attention to what you're doing. So, again, check the denominator first to make sure that it does drop out. 3 times 3 gives you 9. Y to the third times y to the third is y to the 6. So the square root of 9 is 3. The square root of y to the 6, 2 goes from the 6 3 times. So you end up with y to the third power. So some of you have probably already seen that if you rationalize the denominator, whatever that was already inside should be what you had at the end. Whatever was there should be what you end up with. This whole process is just showing you what it takes to get there. But it also shows what you have to do to the top of the fraction. So the denominator should clear out if you do it correctly. Any questions before we continue? So now let's go knock out the top. So we knock out the top. 8 times 3 is 24. X is x. Y to the third, y to the third. You still have to simplify it. So that gives you the square root of 24, the square root of x, and the square root of y to the third. 24. What can I use to break up 24? That can't stay that way. Six, square root of 4 is 2. Square root of 6 stays inside. For the variables, remember there's a 2 sitting out in front. So x means x to the first. 2 can't divide into 1. So I guess that means that x is staying inside the square root. 2 can't divide into 1. 2 can divide into 3 once. So y goes outside, you get 1y stuck inside. So you have 2y radical 6xy over 3y to the third. There's still one more thing that can be simplified. What is it? That's wrong the way it is. Not the 6. Look outside the square root. Those can be simplified. So that simplifies to 2 square root 6xy over 3y squared. Why is it y squared? You have 1y at the top, you have 3 of them at the bottom. And those drop out, you still have 2 left over. That's why it's y squared. So all those simplifying rules from the beginning of the year are now slowly cycling themselves back. So if you got a review, let's review it now before we start getting deeper into it, i.e. once trig gets here. Trig is a combination of algebra with geometry and a little bit of algebra too. So all 3 of them get combined in trig. It's not like the baby trig that you did in geometry. That was baby trig. Any questions before we wrap this up?